Okay, here's another more concrete example, word counting with MapReduce. What we're given here, this problem is that we have a large text file which consists of hundreds or thousands of words, English words, and we would like to find out the number of occurrences for each of these keywords. For example, the, of, brisk, the, and other interesting words. This is a typical example where MapReduce will work very well. Because think about this, you can really count these keywords independently. If you do this job by yourself, you can literally say, now I want to count the number of occurrences of the word the, or next time I want to count the occurrence of the other word. And this can be done independently. So what we end up having in this design is we're going to split this document into these different mapping processors in the mapping stage. In the mapping stage, so let's say we have 100 processors in the mapping stage. So the original document can be divided into 100 pieces. We want to keep them, each of them have similar size. So 1/100th of these original texts will be given to the one of these mapping processors. This processor will look at the list of keywords that we are interested in to count the number of occurrences. Then it will produce these key value pairs. So it depends on how many interesting words we would like to count. Then we will have a number of key value pairs. Now, these key value pairs may not have all the keys, because it may happen that this piece of document that this processor is trying to search does not have the word brisk. It's possible. Even in some document, in that part of the document, there's no word of, which is very unlikely, but it may happen. So you have these key value pairs, and so that's the expected output from the mapping stage. In the reduction stage, we will decide that for all these key value pairs, how we should group them. In this example, as you can see, that what we are trying to do is, for all the keyword of the, we will send that key value pair to reduction processor R0. This is good. So if we have this, basically this mapping, this reduction strategy determined, then we can expect that R0 will be able to have all the key value pairs where the key is the. And of course, once it gets those key value pairs, it will do summation on the values, and that will give us the total number of occurrences of the word the. To have a result produced by R0 that will show that, okay, this particular word, that occurred 26,000 times in the text. Okay. We're going to come back to this example shortly because I'm going to talk about the implementation of this algorithm in OpenCL. There are other tasks by Google and of course other companies can be leveraged, can be addressed using MapReduce. For example, web page accesses, that is to count the number of times a web page is accessed. So in that case, we can use the URL as a keyword, then counting the number of times it has been accessed. Also, there's example of Weblink relationship, which I will introduce next. And also the inverted index, which the mapping processor will try to understand analyze different documents and produce key value pair that match keywords to document identifiers, and also reduction stage will produce inverted index, so you know where the keyword occurred in the document. So for the other example, Weblink relationship, this I try to draw this to illustrate what happens. So let's say we have a way to have these from to URLs. So what this represents is that from looking at these web pages, we are able to get these URL pairs, each of which represent from what URL linked to which URL. So you can think about you have one web page that's identified using this first URL, and within that web page, there's a link to the other URL 6. So you may have many of these by scanning the web pages. So what we want to do here is we want to use these large number of from to these pairs to build a graph that shows the web page relationship. And because this number of tuples could be very large, so MapReduce can be beneficial in this case because these are can be analyzed independently. So what we'll have here is we want to, let's say, group them into smaller chunks and assign these smaller chunks to each of these mapping processors. In the mapping processor, what we want to do is we want to build a key value pair. And in this example, our key is, of course, the URL, the address to that web page. The values here is actually not a single value. It's actually a list of the web pages that's going to be linked from this first URL, from the key. And we can output a lot of these key value pairs. And in the reduction stage, we can group them. In this case, actually, what happened is we can choose to send the key value pairs where the key is URL 5 to this R0. You could have another processor that handles URL 6. But in this case, I decided to have all of them here to the R0. In reality, you may have multiple reduction processors, so you can handle multiple keys on different processors. And on this reduction stage, we will use this key value pair to build the final MapReduce relationship graph.